Good afternoon, everybody, and welcome to TGIK number 95. Hope you're all having a great day. I'm having a great day here in San Francisco. Beautiful view of the bay out there in front of me. I'm kind of looking out toward the ballpark, and I can see the ballpark, and there's a couple of boats out there in the bay. Things are getting a little smoky, but not super smoky yet. There's wildfires happening in California again. All those dry, hot winds blowing things around. Craziness. All right, well, today's TGIK is going to be on some of the security tooling that's kind of coming around and showing up. And I just want to give a shout out to everybody who's joining me here on the session. We've got Olav Kleeman from Copenhagen, Denmark, and Martin from Netherlands. Good to see you both. We've got Dustin Decker right here from San Francisco. Hello. And we got Rory from Scotland and Shahar from Atlanta. What else do we got here? Bogdan from Bucharest and Lamati. Hey, Lamati. And Manvindar Singh from India. And Christine from Germany. Ilko from the Netherlands. And Grigor from Chisinau, Moldova. I probably messed that up. But Philippe from Paris. Everybody tuning in from all around the world. It's such a great thing. This is my favorite thing. Hey, Monty, good to meet you. And we have Alexandra from Brazil, and we have Andre from Brazil also. I wonder if Brazil's pretty big, so I wonder if you're both kind of like in a general, same general area, or if you're kind of anywhere in between there. So we've got Village Strong signing in from Mexico City, or maybe not from since Mexico. We got Robert from Dublin. How's it going, Robert? Good to see you all. So again, this session is going to be exploring a new project that was actually just recently announced by the Cruise Automation folks. That project is called KRail. I chose this image. This is actually, I thought this was like such a fun image because this metal bar is not too dissimilar from KRail, and KRails are one of those things that sometimes skateboarders use as to do slides and stuff like this sort of thing. So a KRail, for those who are unaware, you probably have a name for this wherever you are in the world. A KRail is this cement barrier thing. They usually use it for crowd control. They use it for separating roadways if traffic is opposing. Those sorts of things. That's what a KRail is. And so, if you're wondering what the where the word comes from, that's what it's all about. So another thing we like to do when we get kicked off here is kind of go through some of the news of the week, and so I'm gonna do that now. Let's see what's actually happening in the community. So KubeCon is only a few weeks away, and we have. Well, let's see. Looks like I missed a link here. There we go. So Nancy Lancaster, who is one of the people who is responsible for handling kind of the some of the work around managing the scheduling for all of the amazing talks that we see at KubeCon every year, has put out a request. If you are planning on actually attending KubeCon, please take a moment to go ahead and fill out your sessions in sched.com. And this actually helps them figure out what the right sized room will be and that sort of stuff. So if you have a moment and you're planning on attending KubeCon, this is a great way to go about it. So a great reminder to go ahead and fill that stuff out. And there's a link from that tweet directly, and we should really we should help Lancy out. She's awesome. And also, I wouldn't want you to show up at KubeCon and not be able to get into the session that you're like eagerly awaiting. So if you get in there early, then you're pretty much guaranteed a spot there. Like if you try and show up like a day of, sometimes that gets a little tight. So just a heads up. The next thing we have is a note from our good friend George. Wanted track hosts for KubeCon and Cloud Native Con. This is talking about a particular track host schedule, and so definitely give this a read. This is familiar site. Well, this looks actually kind of fun. I wonder if I'll have time for this. But the idea of this is there are still 20 sessions without track hosts, and what they're looking for is somebody to kind of bring a little bit of continuity to it. It sounds like. make sure the session starts and ends on time, maintain the integrity of the session. Sponsors should not be passing out anything to attendees or scanning badges. We're looking for volunteers to fill some of these roles at the con itself. So if you're interested in doing that, this is how you get involved, right? Like this is everything we do, including KubeCon, is very much community focused. So I mean, if this looks like something that you'd be interested in doing, definitely jump in and help us out. Next up, we have Vito Bitten has written a cool Valero backup notifier for email and Slack. So Valero, if you are unfamiliar with it, is one of the projects that we developed at Heptio, and the goal of Valero is to enable you to back up not just etcd state or just the state of those resources within your cluster, but also any volumes that you have associated with them. So as we think about models for actually backing up and restoring stateful applications to a single cluster, or maybe even moving them from one cluster to another, Valero is some of the community-based tooling that we developed at Heptio and is now under the governance of at VMware to make all of that possible. So it looks like Vito has written a project that is about a Valero backup notification, so that when your scheduled backups take place, like if you've gone ahead and set up a cron job to perform a particular backup, that you actually get some notification from the result of that. And it looks like they've got a few different options. They've got Slack and email to make sure that you are notified when those things take place. This is true for backups or restores, and that's a pretty cool feature. So that's pretty great. Another thing that's neat about Valero, and actually a lot of the tools that we've developed at Heptio and now at VMware, is that a lot of that development is done right out loud. So like all the developers on those projects, Valero, Contour, Sonobuoy, all of those things, that is actually, these are, the dev chat for that is in Kubernetes Slack. And so like the developers who are working on this piece, or even the folks in the community like Vito that are interacting with with the teams that are working on that project, they can jump right into those channels and like interact with the team to ask some questions about why particular design decisions were made, or whether a particular idea is a good fit for the project. All of those things are available to you, and that I think that really signifies kind of the open source nature of what we're trying to achieve here. So move forward here. Kubernetes patterns, the service discovery pattern. So this one is about, let's take a look. So this is a nice blog by Mohammed Ahmed, and he talks about service discovery and how service discovery works within Kubernetes. So this should be a pretty interesting read. So Kubernetes deploys applications through pods. We know about pods. In microservices application, the application is broken into a number of components, and they kind of need to be able to discover each other so that they can intercommunicate between those pieces, right? I think of this more in terms of distributed systems rather than microservices, but they're mostly equivalent. So client-side discovery means the client is responsible for determining which service it should connect to, and it does that by contacting a service registry component. In Kubernetes, we do this with DNS typically. In server-side discovery, in this model, the load balancing layer exists in front of the service. I see. Yeah, so this is actually a really interesting article that goes into some of the different patterns around service discovery. He does describe how the environment variables are set, although interestingly, there is a bit of a race for those, right? So these environment variables cannot be updated once the pod has come up. So if you want to rely on environment variables for service discovery, then you also kind of rely on defining services in an order that those services are available to the pod when they start up. Otherwise, you can use DNS, and DNS is dynamic, so it wouldn't really matter what order you're actually making use of. What else do we got here? External resources, which are interesting. It's another type of service. So you can define a service of external, and that will actually allow you to effectively abstract away the name. So if you're in different clusters or working with different projects, you can have a common name that represents some external resource, so you're not having to define it uniquely in every one of those environments. You can actually use DNS as an abstraction for that. That's actually pretty cool. He talks about node port, talks about load balancer, kind of getting into services pretty heavily here. Also talks about the headless service, which is one of the only services that is not managed by kubeproxy. So that's pretty interesting. Yeah, definitely worth a read if you're interested in this stuff. And this actually reminds me, I was going to mention that I've actually been doing a series of things on grokking Kubernetes, and I'm going to continue that series. But I thought, I'd take a break from it and do something else this week. And so I think the next up for the grokking series is scheduling. But we are going to get back to it, and I'm going to keep doing that series. I'm just taking a break this week, so just a heads up there. Let's kick back to the crowd. We got Antoine from Paris, and we have George putting up the notes. Remember, you can get your notes at tgikio/notes. That's where you can find them. And the Maddie is asking, would you mind talking about how KRail works? Yeah, that is absolutely the goal of this session. That's what I'm going to be doing with a lot of my time in this session, is like kind of comparing KRail with like pod security policies and stuff. Alex Ellis, who put up a pretty good blog post describing how to get a load balancer for your private Kubernetes cluster. And this is actually a really interesting project because it enables you to actually expose services within, say, like my kind cluster. I could expose that to an external endpoint hosted perhaps on AWS or on DigitalOcean. And that would give you, the audience, the ability to access the service that's running on my laptop. And so that's actually a pretty cool feature. And if you're looking for, that sort of an environment or that kind of capability, Inlets is actually a pretty interesting tool for that. So I'm not going to get into crazy detail here, but definitely check it out. He shows you a couple of different ways to do this with K3D and also with Kind. I had the pleasure of actually chatting with Alex about the kind of the TLS implementation and how all that works. And it was really, he's a very responsive person. And if you have questions about how it works, definitely reach out. Yeah, it is pretty neat. I've been planning on actually doing a little bit more work on myself. Next up, how do we roll back deployments in Kubernetes? And this is actually one of the topics that I'm going to cover on the grokking series at some point, but if you're looking for a little preview, let's see what they've got here. So Kubernetes has a built-in rollback mechanism, which is true. You have a service and deployment. You have the powerful replica set. And this is absolutely the case, right? So your deployment, when you create a deployment construct within Kubernetes, that deployment construct is broken down into its component parts by the controller manager. So as soon as the deployment shows up, the controller manager replica set controller will grab that deployment or see that there are no replica sets associated with it and then create a replica set. And the replica set controller will then create pods. And so we walk through that whole process. But what's interesting is that because of the way the deployment construct works, you actually end up with multiple replica sets depending on when you change the configuration of that deployment spec. So if you change the deployment, we keep the old replica sets around in case moving forward doesn't work. Like how do we actually, if I updated my deployment to the wrong image name, it would start crash looping, right? Or image pull back off or what have you. And the question is like, how would I be able to go back to that previous one that had the correct image name while I go figure out why my new image name is not populated in the container registry, right? And so this is what this is describing. It's like some of the capability of being able to basically move back to the previous replica set. So this is an official command that you can actually manage, and you can also govern how many replica sets are actually kept. And that's where this revision history limit is managed here. And so, yeah, good article on deployments, and definitely a prelude to understanding those things a little bit. So this one is actually, this next blog post is actually by Madhukar talking about understanding the Kubernetes API. And what he is describing here is basically how to use kubectl proxy to expose the API directly. And that totally works. Like you can actually even grab the Swagger document from the API using that model. What's interesting is that kubekettle proxy is not specifically a requirement. When you use kubekettle proxy, you're authenticating as yourself, so you have access to everything that you as an authenticated user has to the cluster. But there are actually other ways to do this. You can do this with kubekettle get --raw. There's all kinds of interesting ways to get this data. And so what they're describing here is like how you send an API request, what the resulting of that request looks like, and kind of opening up the idea of interacting with the Kubernetes API as a RESTful endpoint. So pretty cool stuff. Then we have a couple of submissions by Mr. Bobby Tables. We have the volume plugins for FlexVolume to CSI, and then we have the bare metal cluster installed with Cluster API. Let's look at those two interesting new projects, or not new projects. This one's been around for a little while. So FlexVolume plugin, or the minimal viable fishing rod. What does it mean by that? FlexVolume is an executable file, binary file, Python script, bash file, what have you, that takes command line arguments and gives you the ability to effectively define when a pod is trying to access a volume, like what business logic is necessary to accomplish that. And FlexVolumes are being used for a number of interesting projects that are out there in the space today. One of them is the Vault CSI driver, right? The ability to actually, so that you could, define within your pod spec that you want access to a particular Vault secret, and then the implementation of going and fetching that secret and making it available to the pod can be handled by FlexVolumes, because it really provides you some capability here. So this blog post, I think, just digs into like what FlexVolumes are and some of the ways that you can actually explore them or extend Kubernetes to support volumes that perhaps didn't already exist, or are more specific to your particular infrastructure. So definitely worth checking out. Let's go back to our chat, see how everybody's doing. We have Vadim from the Ukraine. We have Dmitry from NYC. We have, I talked about this the other week. I think you did, yeah. Overheard, Joe Beta. How to persist events we see on kubekettle get events. Sorry if it's out of, oh, I see. Yeah, we can talk about that money. That's a good question. Want to find time to play with Alex's thing? I agree. We have Sam from Melbourne, Australia, and Bogdan asking, oh yeah, very good point. I was actually about to share that very thing. Thank you very much, Bogdan. Herman Hintz saying hello, how's it going? We have Joe tuning in. Yep, all right. Let's see what else we got here. So this is actually an exploration of the Cluster API provider. And in this presentation, this person explores what it's necessary to effectively develop a provider against a virtualization library, right? So they first go in through and kind of describe what Cluster API is. We spent a bit of time on Cluster API within the TGI. So there's a number of different sessions that talk about Cluster API, both, I mean, even like way back in the Genesis when we were still kind of playing with this idea, all the way up to kind of like what is available currently. So definitely worth checking out. It's got a pretty good summary of what's there, like some of the primitives that are exposed by the Cluster API. And then what's interesting is they talk about like, when we describe machines or machine classes, we also have to kind of wire up a provider or an actuator, which is responsible for handling the heavy lifting, if you will, or interacting with that infrastructure as a service to create the thing that you've asked it for. And in this document, I think they go through a pretty deep dive into what that provider is going to do and ways to leverage it. So in this example, they're talking about leveraging libvirt or KVM to interact with as a provider for Cluster API, which is a great way to learn it, right? Because if you're looking at exploring Cluster API or perhaps developing a provider or anything else like that, this gives you all the tools necessary to kind of play with this whole idea. This is an incredible topic. And it's actually a really good blog post. So it's a really good jumping off point. Good shout out to the amazing amount of work that this person did to really get this done. So nice work. I want to call them by name. Nice work, Himani. That is that is awesome. So very, very cool. Definitely check that out. And then the next one, let's see, what else do we have here? We talked about that. Notes on K's reliability. So this is a link from Jim Angel. Distributed systems such as Kubernetes are designed to be resilient in failures, which is true. There's the whole level set construct. We talked about this a little bit on TGIK. To have a simple view of how most parts of HA will be skipped to describe kubelet controller manager communication only. Okay, so in this document, they're basically describing kind of like, you know, how does it actually work, and they provide some understanding of some of the tunables with regard to the kubelet that you can use to kind of, to tune how long the API server waits to understand whether a node is in a healthy state and how frequently the node updates the API server with its current state or with its current understanding of things. And they specifically talk about some of how some of these tunings, some of these tunables are specific to the size of clusters that you have, right? And how many events those things represent, and what sort of a load that represents on the backing stateful store, like on etcd. So this is a really good read if you're in the process of trying to understand, like, you know, like, why does etcd seem like it's always super busy? Here are some of the tunables that we can do to kind of like improve things, depending on the scale of the cluster or the scale of the events and that sort of stuff. So that's definitely worth a read. And 117, we're almost done with this part of the show. The 117.0 Alpha 3 is out the door. And I believe it was actually recorded. So if you're interested in understanding more about the release process, there's a recording for how this was done. But yeah, we're already talking about 117.0 Alpha 3. 116 is out. And that brings me to the next piece that I wanted to talk about. And if you're interested in understanding more about how patch releases work and what the cadences are, information about how to get code fixes from one branch to another or into a different release, and also target dates for when particular releases are going to happen. This is a live document. It's updated pretty frequently. So it definitely gives you a pretty good understanding of where we are with things. So this can actually be found underneath SIG releases, patch releases, and this document, the link is right there in the notes. And I think frequently when people start adopting Kubernetes, they start asking questions like, okay, well, how often does it change? You know, what does my adoption process need to look like for me to actually stay in tune with what's happening upstream? And we're developing things like, you know, cluster API and those sorts of things to really sort of address some of those issues. But 117 in 2 sentences, I am not going to take a shot. Yeah, I think there's a lot. I don't think that 117 has been quite as heavy a change as 116 has been. But what I will tell you is this: if you're looking to understand some of the stuff that's changed in Kubernetes over time, there's this great website that's put on or managed by Josh Berkus inside the community, where he does a weekly report of what's actually happening with PRs that are merging and stuff like that. So like one of the things that actually happened recently was the billion laughs thing. And so he's describing some of the PRs that have been merged to fix things like removing Hypercube in 117 that'll be removed. Just a lot of updates like weekly where we start talking about those things that have changed. So if you're looking for like a bridge notes or like a crib notes for like what's actually happening with the code base on a weekly basis, I highly recommend Last Week in Kubernetes Development. It's really great. And then I wanted to show you this, which I think is actually pretty neat, and I'm going to take this opportunity to again remind you. I should actually put that in the notes so don't forget. You can do this too, you know, I don't have to do it. So inside here, show notes, you can just go lwkd.info. So that's the link, lwkd.info. Definitely go check that out. Kubernetes podcast actually also does a pretty good way of aggregating information. Hey, there's Tamal. How's it going, Tamal? So cool. The next thing I wanted to show you was this project called Deprecate, and I was actually working with the folks, with the gentleman who's like behind this, Nicholas. And Deprecate's actually pretty interesting because what it's trying to do is it's trying to enable you to leverage a project called ConfTest by Gareth Rethgrove. And ConfTest is a tool. I think it'd be kind of if I do another session on OPA, which I'm thinking about doing. It's definitely worth talking about kind of the ecosystem around the tooling. So like there are things like you can leverage OPA to do admission controllers, and you can also leverage OPA and Rego to do a lot of really interesting functionality around ConfTest. In this week's example, I'm going to show you this one, which I think is actually super neat. Somebody basically, Nicholas wrote the policy around reporting on APIs that will be removed. So one of the questions that people are asking lately, and we have a proactive campaign around this right now at VMware, our CRE team does, that are basically just kind of like, how do I go about validating that all of the manifests that I'm using inside of Kubernetes are actually up to date? Or are some of them, are the manifests themselves still going to hit those removed APIs in 1.16? How can I determine that, right? And so in this, so what this policy is doing is it's going through and it will actually just report back when it sees a policy that's being used that has been deprecated. So very cool project, definitely worth checking out. And as an example of the output, he provides an example of that here, right? An example of the output, if you go ahead and grab the deprecate rego and you use ConfTest directly, you could use something like Helm template to go ahead and validate the configuration of things, right? So in this example, he's going to grab Helm template. He's going to do a test against the configuration that he has for Prometheus, and then he'll be able to see that there are a number of templated files that result in APIs that have been removed, right? And that's actually a pretty handy thing for a lot of people who are actually working with it. So definitely check that out. I was really pleased with it. And actually, one of the things that Nicholas and I were talking about was there are a number of ways to present that data to ConfTest. You can present that data as hyphenated chunks of YAML. You can also present that data as a list of YAML documents in Kubernetes basic form, right? And one of the changes that he recently made was to enable both of those models, right? So it doesn't matter how you present it now to ConfTest. It could be a list of YAMLs according to the way that Kubernetes lists it out, or it could also be a dash delineated YAML documents. However you want to get there will work. Pretty cool stuff. The other one I want to show you, which is something that I put together for, where did I put it? So the other thing I wanted to show you, but for some reason have hidden from myself, which is weird, is that you also have the ability to determine if the deployments in those things inside of the cluster are created with a deprecated API. So let's do here. And I'll show you that when we get started here. So I think we should just go ahead and get started. You mean EC2 bare metal incident? What are we talking about? Yeah, ConfTest is actually very cool. There's another one that Gareth wrote, which was Cubeeval, K-U-B-E eval, which is more specific to Kubernetes, right? Cubeeval. Yeah, instrument A stuff is really neat. So Cubeeval gives you the capability to validate, to do some strict schema stuff and to do like validation of the of things according to the what do you call it? The Swagger document known by your Kubernetes cluster. So this is another one of the kind of interesting things that you can use to kind of validate manifests so that you understand whether fields are missing or if you have a typo. But this is more specific to Kubernetes. Conf-test is kind of more general. You can apply conf-test across a variety of things. It doesn't even have to be Kubernetes. It could be any document, like or any YAML or JSON. I think it's both, but I can't remember at the moment. But you could do kind of more wide, like you could use it to evaluate other things. So that's actually pretty cool. So let's get kicked off here. I know it's just about half hour after the mark. That was a lot of pre-work, so let's get into the fun stuff here. So what I'm going to do is I'm going to kick up my cluster. And delete cluster. And I like that it doesn't take any longer than this, right? Like it's actually really quick. So I'm going to create my kind cluster, and we're going to use this kind cluster to kind of explore KRail and get it played with and stuff. And so we're going to walk through the install doc, and then we're going to play with what's there. And I'm going to show you some kind of interesting things that we can do to kind of hack around and play with what is available to us within the tooling that's been provided. What's the difference? What's that spiffy Google background you have there? I'm not sure. You mean the background of my laptop or the background of my head? Let's get this thing turned on here. Oh, I'm not sure. We got our control plane up. We're kicking up our worker nodes. Now, what's interesting here is that, like, so KRail. Let's go ahead and look at the docs while we're waiting for things to boot up here. So KRail is a validating webhook that gives us the ability to deny or allow deployments or all of the things that make use of these sorts of things directly, but because it's a validating webhook, we don't actually have to modify the API server the way that we do for pod security policies. But at the same time, I think it's really interesting that if you think about it, that means that there's sort of like a timing attack there, and we're going to play with that a little bit as well. But KRail acting as a validating webhook gives us the ability to define what configuration we want it to actually enforce somewhat more dynamically, and so that's actually pretty interesting. TGIK. Oh, I see. Yeah. TGIK.io/notes. Correct. That is the right one. Thank you for noticing that for some reason the URLs are hidden, but good enough. I see only worked with EBS-backed PVCs and EKS. That works also. Fusion with using PVs in a deployment. Well, I guess while I think it's probably up here, so. So, to give you a quick answer on the stateful set versus deployment with PVs, I'm going to give you a little insight into this. So, deployments are meant to be a thing that you can just scale horizontally. And if they have a volume associated with them, it's assumed that that volume is either going to be like an empty volume that you could use for like caching or something like that. That would be specific per instance. But if you make use of a persistent volume in a deployment, then only one of the instances within that deployment are going to get access to that persistent volume unless you're using a technology like read-write many, right? If you're using read-write many, something like NFS or EFS within AWS, those sorts of things, then you can actually mount that, or even read-write only, or read-only many. Is that right? I think it's just read-only. But volumes that can actually be expressed that way can be mounted across the entire set of instances or pods associated with a deployment. But there are some real caveats here, right? Some sharp edges for sure. Because each of the deployments is expected to be effectively just a horizontally scalable unit. So they don't really have their own identity. You're not going to be able to mount those things uniquely to each point. And so the volume as expressed to the pod is going to be exactly the same on all of the pods. Right? It's going to be the same volume expressed in the same way to each pod within a deployment. And sometimes that sets up kind of a rough model if what you're trying to do is something like create a database, right? Because you would perhaps want a different path for the backing store for that volume. And that's where things like stateful sets and daemon sets come in, right? Stateful sets give you a completely new feature, a completely new capability when you think about stateful sets, because with stateful sets you have what's called a persistent volume template. And that persistent volume template gives you the ability to define what storage you want to associate with each pod uniquely. So now each pod has its own persistent volume, its very own persistent volume, not shared with all the other pods. And each pod has its own unique host name, right? It'll be, usually it's like pod name -0, pod name -1, pod name -2. And you also get ordinality out of it, right? So you also get the ability to define the, make use of the fact that in a stateful set, they will come up one at a time, one after the other. Whereas like with a deployment, it's going to be wherever we can fit it, we're going to have it come up in whatever order works out. So interesting stuff. But yeah, this is a very good question. Thank you, Bogdan. It's a very good question for the Kubernetes Slack. So definitely go check that out. So it looks like we're probably all the way up and running here. So this cluster is up, and I haven't done anything to configure it. I want to just look at the config real quick so we can understand what's happening here. I've not overridden any settings. I've just basically set the pod and the service siders, and I've got 2 workers and 1 control plane, and that's all that's really happening here. So let's get into the KRail side of things, and we're going to go through the install. So where's the install doc? So you can install or update KRail using a Helm chart in Deploy Helm. Ooh, and I like this. Like in their document, they actually show leveraging Helm template, which is really great because Helm template means that you can actually go ahead and just use, with Helm template, you can generate the manifests that will be used and then apply them to the cluster using kubectl apply. That's actually what's happening here, right? So we're generating the manifests with this command, and then we're going to actually go ahead and create those or deploy them to our cluster with our kubectl apply command right after that. That means that there's no tiller running in the cluster. There's no requirement for tiller to be a part of this mechanism. They're just using it to actually handle the templating of that, which is really cool. I like that a lot. So let's get started here. What I need to do though is I have to check out this repository. So let's do clone. And let's see what we get out of that. Like, let's take a look at what's happening here. So this is what I meant by, actually, this is a great segue into what we were talking about before with that conf test command, right? So this is a bunch of manifests that are hyphen separated, right? And so I can do things like, so this represents a list of YAML documents that are hyphen separated. But generally speaking, if I were to do, if I were to interact with Kubernetes and ask it for a list of resources outputted in YAML form, it would provide me a list object that comprised all of the things inside of it. So we have a pod disruption budget. We've got a config map that has been templated. We have an exemption class. We've got another config map that describes the KRail exemptions, which looks like it's just allowing everything inside of the kube system namespace. We have a service that's been defined, and that service is actually in front of the validating webhook. What else do we have? We got our deployment. Oh, and it's apps v1 beta 1. Let's try this out. Remember we were talking about conf test earlier? I do have it. And then let me see if I have, that command that we were running earlier. I want to show that real quick. So let's go ahead and do that. Deprecate. Okay, so then we can do our Helm template command, and then we will do conf tests. Test-p. And something will be very unhappy with us. Oh, whoops. Okay, I put that after the wrong file. There we go. Conf tests. And we see our error. This is actually what I was talking about with conf test, right? So what we've just found, pardon me. What we've just found is two outputs from that conf test command that I showed you earlier. One of them telling us that the validation webhook configuration is against a deprecated API, that it should be moved to v1 rather than v1 beta 1. And the other one is a fail. In 1.16, this deployment would fail to deploy because the deployment is using apps v1 beta 1 instead of apps v1. So that's what I'm talking about by the value of the conf test piece. And here in a minute, I'll also get to show you, because of this, I'll be able to show you like some of the stuff that is also interesting. Make sure you don't template into the default namespace, or the non-compliant deployment example won't work. Yeah, I'll get that worked out. Thank you, Dustin. All right, so that's what I wanted to show you with the conf test stuff. Pretty cool stuff. I'm like super excited that that's actually something that people can actually use to make sure that they don't get burned by. It's part of the deprecation policy that we remove them after a period of deprecation. Many of these APIs have been deprecated for years. I mean, like almost as long as I've been working on Kubernetes. And so I think that our goal is to actually just maintain, to define that policy and to stick by it. And so this is actually, in 1.16, we kind of ripped the Band-Aid off and we said, like, look, those things that have been deprecated for years are due for removal, and we made the move to actually do it. That's correct, yeah, after 1.16, many Helm charts are not working. But this is a way to actually see that that's going to happen before, right? And then you can actually contribute to the change that would actually help. It would really be good with your CI pipelines, agreed. All right, so let's move into here, and let's go ahead and do our deployment. Let me go back to the docs here. So our docs on install. Oh, okay. I noticed this before, but I haven't checked it again to see if it's been fixed, but kubectl get secret. Ah, it is. All right, so now the secret is actually in the namespace. Let's go into our namespace that was created. It's called namespace KRail. So KNS KRail. We'll do kubectl get pods. We can see KRail is up and running. All right, good deal. So we now can do kubectl logs. We'll do get pods. Show labels. Kubectl logs -l name equals KRail. and we can see those pods doing work. So they're loading all these policies up, and in enforce mode, and it gives us a period of time in which it's doing stuff, right? So let's go ahead and look at some of these policies that are being defined here. So, I mean, first I want to say, like, what we've got right now is a fully set up thing, right? It's actually working. We've got it running inside of our kind cluster. So, yay, install docs. Like that worked right out of the box. I love that. So, and we have a couple of different options here. It looks like by default it'll deploy in enforcing mode, and you also have a report only capability where if you don't want to necessarily enforce those things, but you do want to be warned that those things are being done, then we can do these things. So let's talk about what those things are. So these are supported policies. These are some of the policies that are available within KRail, and these are policies that Cruise Automation folks, and I think in agreement certainly with a lot of the community, consider to be kind of like high risk capabilities that are exposed to any authenticated user within the cluster. And so what I mean by that is that literally any authenticated user can request any of these things when just creating a pod spec. So some of the policies that KRail highlights here are bind mounts, right? And so this gives us I definitely refer to it as, oh my god, host path, because as I'm sure all of you have heard, everything in Linux is a file, and because of that, if you have the ability to mount in the underlying file system inside of your container, then that means that you also have the ability to get a hold of paths that are maybe not so great. Like, for example, I could mount in the underlying host's proc file system into some other directory within a container, and then just go tripping through the environment files inside of the proc file system to see if there are any valuable juicy secrets in there, right? So there's lots of things where bind mounts or host path are really a bad idea. Another thing that could be used, depending on how you've got your cluster set up, like you might just grab the kubelets credential and escalate your privilege, right? Now, typically we've got things like node restriction in place to kind of lock that down, but yeah, not quite what I'm talking about, but close. So in this case, they're talking about that when they're talking about Docker socket mount. But I'm talking about host path, right? So host path is my ability to say, create a volume of type host path and mount in /etc or /proc into my container, right? And so any user can do that in the absence of admission control, which is what this represents, right? So we're leveraging a validating webhook to protect that admission control enforcement point to knock down some of the kind of higher risk capabilities that any user can make use of within Kubernetes. The next one they highlight, I think this may be just a little too specific, but it's definitely worth doing if you are in a Docker-only environment. So what this one does is it says, this is a little bit redundant also, because like up at the top you have no bind mounts, but down here we say no Docker socket mount. So even if we did say you could do bind mounts, then we're also going to be able to test whether the Docker socket is being mounted in. So it is recommended to use the no bind mounts policy to disable all host path mounts, but if you don't do the no bind mounts one, then this way you could at least limit the Docker socket. This one is actually a really interesting one, and I spent a little bit of time talking about this. The Docker socket is effectively an unauthenticated API. And so if you have a cluster with Docker underneath, and you're going to make use of something like Docker in Docker, so you can do things like your image builds and push those things, if you have that set up so that you're expressing the Docker socket as a file mount into the container, then what that means is that you have the ability to easily escalate your privilege in the underlying host. And I'm going to show an example of that in this session, and we're also going to try and make sure that that gets shut down by the policy here. So we'll play with that. The next one up is the immutable image reference, and this is a reasonable one, but what this is actually doing is basically enforcing the idea that when you ask for an image, that you want to make sure that the image that you pulled down is the one that is made available to you by your registry. And it highlights the fact that the Docker tag is entirely mutable, right? I can push images all day long with different contents to the tag Alpine 3. Well, I couldn't push it to Alpine 3.8, but if I'm in my own registry, right, I could just reuse that tag over and over again, and all it's going to do is basically point that tag at a new SHA. Very similar in some ways to Git, if you think about it, right? Same thing. I can move a tag anywhere inside of my Git history. And that means that it's effectively mutable. That tag is only so valuable when we think about like being able to understand that the thing that I pulled down is the thing that I'm running. And so in this case, our goal here is they're trying to enforce that if you're going to use an image, that you should use the immutable image reference, so that at least you know that when you got that image from Docker or from whatever your registry is, that image is the same image that you deployed. It's not the tag. It's the image reference, and that's actually it's a pretty good idea. I think it does kind of raise the barrier of entry a little bit, because a lot of people are really more used to the idea of tags rather than image references. But it's a solid idea. What's challenging is, and I was actually just seeing, on Twitter, there was somebody pointing out, and this is very true, that there's really not an easy or usable way for most of the time for you to actually link back to the source code associated with an image reference or a tag. And that's, you'd have to entirely own the entire supply chain for you to actually be able to provide that. If you're using images from somebody else, or if you're using images that you didn't build entirely from scratch, then yeah, there's some risk to that. It's a pretty interesting problem. The next one up, no host network. No host network means that you don't want pods to be able to make use of the underlying host network, right? So those pods couldn't do things like, capture traffic going to another pod, or down interfaces, or generally wreak havoc, or bind to a external facing port directly into a pod. Those sorts of things, right? So host network gives you that capability. And generally speaking, when you grant host network, you also give the ability to do things like understand. You may extend privileges further than you think by enabling that container running as root with access to the host network to be able to do things like dump IP tables rules, or modify the direction of traffic, or manipulate packets. There are things there that are definitely sharp edges. So it's reasonable to cut down host network. Host PID is another one that's interesting, and I'm going to show this one off a little bit as well. Host PID gives you the ability to actually understand the host PID's namespace. And so when you're inside of a container with host PID set, and you type ps-ef, then you actually see all of the processes in an underlying host, not just those processes that make up your container. Because if you think about it, containers really are, at the end of the day, just process isolation. They don't really do anything else. And so it's an interesting point. No new capabilities is a good one. No new capabilities means that you want to limit the capabilities of any given process to only those capabilities necessary that the application itself needs. For example, most of your applications probably don't need the ability to create new network namespaces, or to do things like flush the IP tables rules inside of the associated network namespace, right? And so these are capabilities that you can enable or disable by default. And what they're looking for here is to make sure that when the pod is started up, that no new capabilities are granted to that pod during runtime. Privileged containers, you've heard me talk about. Privileged containers are like a really bad idea for lots of reasons. Privileged containers have the ability to do pretty much anything, including access any of the devices in the underlying host. They have the ability to, from a privileged container, you can enter into any other container, or into any other C group or namespace associated with any other container. You can just literally hop over to another process running inside the system. And again, we can demonstrate that in this session as well. So no Helm tiller. They definitely see the value in templating with Helm, but maybe not running tiller locally. And this is a topic that we've really spent a lot of time on here at TGIK. So I'm not going to burden it, but I'm really looking forward to a session on the next version of Helm, Helm 3, which I think will be probably the next time we really talk about that one. I think we're pretty close to all of them, but I want to just talk through them real quick because I think there's some value in that. The next one here is a trusted image registry, and this is actually, I think, pretty valuable because it gives us the ability to define those registries where we will allow images to be pulled from. Now, this is a validating webhook, which means that in your pod spec, in your deployment, you're going to have to specify that correct registry ahead of time. Right? It can't modify that registry for you. And so it's actually specifying, and so in this case, they're providing a list of repository regexes that are allowed or trusted registries that are going to be used to pull images from. So definitely check this out. It's very cool. I would say that this is probably more than just official Docker Hub images. It looks like it's everything, but you get the idea. Oh, I see. They're saying this is official Docker registries because they're saying if it's just a name and not anything with a slash in it, then like if you just typed nginx :latest, then this regex would match that because it would actually, yeah, exactly. All right. Please keep this video on my channel. It's 2 a.m. here, and I may pass out anytime. Sleep well, Monty. You deserve rest. I know it's late. Require ingress exception is a policy which requires configured ingress classes to have a policy exemption to be used. This is typically useful if you want to gate the use of public ingress. That is interesting. So this is basically saying if a person creates an ingress for an ingress object within their namespace that is going to make use of this particular class, nginx public, then we want to really govern like whether that is allowed or not, right? And so you can actually specify, again, kind of like up here at the exceptions or the exemptions, that's down below. You can specify in exemptions like whether that particular namespace is able to define ingresses of that type. And so this will be fun to play with as well. There are multiple levels of logging that they've enabled in the code. They've enabled debug, warn, and info. By default, it's info, which is actually pretty useful, it looks like, from the output. There are a couple of different modes of operation. There's a report-only mode where it doesn't actually deny anything. It just sits in a global report mode and just tells you, when it sees things that it would have affected, which is a great way to adopt a tool. I do sometimes wish that pod security policies had that capability. That's a good idea. And then policy modes. Policies configure a validator that can be enabled or disabled, run in report only or enforcement mode. So by default, we're running in enforcement mode. And then lastly, they have this policy exemptions piece. And this is governed by, they don't explicitly call it out here, but this is governed by a config map inside of your configuration wherein you can specify inside of your Helm values here, you can actually modify that via the Helm values and then retemplate, or you can also just interact with that config map directly. And that's, for our purposes, that's probably what we're going to do. Some policies are configurable. Policy configuration is contained in the KRail configuration above. Documentation for the policies configuration can be found in the supported policies heading above. So they have the ability to, they're saying that all new policies must satisfy this interface. Which means name must return a string that matches a policy name that is provided in configuration, validates an accepted admission request, and the resource of interest must be extracted from it. See resource pod go for an example of extracting pod specs from an admission request. Makes sense? Policies can be registered in internal policies go, and any policies that are registered but do not have configuration provided will be enabled in report only mode. So it's not, you can do some policies in report only mode kind of by default, unless they're actually registered and have the ability to be enforced. So that's actually pretty cool. So if you're developing new policies, you have the ability to kind of like iterate over them before actually having to modify them, or before having to, commit to them. So resources they've got some debugging logs, capability here, kind of giving you some view into it. They have metrics that they've exported. Well, that'll be interesting. Let's go ahead and check that one out. So I'm going to interpret this. So what they're doing here is they're saying to use kubectl proxy, and I'm going to use kubectl get raw because that's how I roll around here. So get raw. No output. So we're definitely getting metrics. grep KRail. KRail? Rail? Nope. Nothing. Maybe we haven't done anything yet. That could be it. All right. So, but actually, you know what we should see? We should be able to see our validating webhook defined, and we do. Nice. Okay. Well, we can actually look at the configuration of that validating webhook here in a second. So before we do that, let's move on. We've got policies enabled. We have deployment is blocked and exception is needed. We're going to play with that live. We're going to play with that one. And then they also have like an MTLS certificate request. So if you want to understand when that certificate will expire, let's take a look at that one real quick. I think that's kind of a fun one to do. So this will expire in 10 years. So we should be good for a while. All right. And that, I think, is all of the doc that we need to play with. But we're going to start playing with kind of exemptions and examples here. So let's go ahead and play with making stuff that might break this thing, or, like stuff that it would enforce. So I think they actually have an example of a non-compliant deployment. So let's take a look at that one, and then we'll play with that and see what we see. First, I want to go back to the chat. Monty agrees that he deserves sleep. It's important. Sam says, we found soft fail audit mode was critical to roll out without, yeah, I completely see that. Dan says, Mr. Pop, how you doing? Dan Pop is Dan Papandrea works at Sysdig and a good friend of mine. Looking forward to seeing many of you at KubeCon. It's going to be so great. Yeah, and Joe said the same thing. Oh, maybe I missed a little more in background. Where I can, I like to tag images. Yep, I like that idea. That's true, Joe, and that is a reason why a lot of people use Docker and Docker, and we can kind of talk about that in this session as well. Yay, Robert! Does not appear to have valid DNS hostname. What? LWKD. My bad. Thank you, Rory. Awesome. All right, let's get into it here. So, our example of the non-compliant. Woo! Yeah, that's very non-compliant. All right, so here's what we got, like directly out of the box. That was really great feedback. Like almost immediately, we got like a ton of information back, like right away, which was very helpful in understanding it. So, but let's look at some of the output that we get here. We get error from server, KRail admission review. So that's really helpful. It gives us a breadcrumb to tell us like what is actually producing this output. Error when creating deploy non-compliant deployment YAML. Admission webhook, KRail cruise automation github.com, which is what we know it to be. Denied the request. It's been denied because it has a bunch of volume mounts. It looks like a host bind mounts are forbidden. The Docker socket is forbidden. Immutable image reference is forbidden. The no host network is forbidden, no privilege container. Boy, this thing, let's just take a look at this manifest. kubectl get, hold on. This looks like a fun manifest. I want to look at it anyway. So this is a deployment using apps v1. Yay, that one's fixed. The host network is set to true. Host bit is set to true. They're mounting in var1 Docker socket. They're mounting in the host root path and overriding. Wait. Oh, this is just the volume, and then where it's mounted is a different place. So yeah, it's mounting host path into /host. We're giving it capabilities like privileged and netadmin and sysadmin, which is a little bit redundant because if you have this, you have all of the privileges, all of them. But they're putting it in here so that you can actually see the error, and I totally get that. And then we define an ingress using the ingress class public, and we're trying to deny that as well. So cool stuff. Let's go back to our log output. Yep, and it says require ingress, so we actually got that as a result, and this is why we see it happening again, right? Where we see more input specifically from the KRail admission controller. So this is two different outputs. This is one output for the pods and one output for the ingress object. And each of them actually gives us information about like the thing that we're trying to achieve here. So that's pretty cool stuff. Now, one thing I'll point out, which I thought was kind of, this is actually one of the challenges of admission control webhooks in general. One thing I'll point out is that if you think about it, there's a bit of a timing attack here because it's a validating webhook, right? In that anything that I had defined in the cluster before running it will still be there and still be running because it was allowed admittance before the admission webhook came online. Are there any valid reasons to mount the Docker socket into a container? Nah, not anymore. I mean, like with things like image and some of the other tools that are out there for actually handling the build of Kubernetes images, or of Docker images and managing those things in kind of a more secure way, I really have a hard time believing that there's a good reason to do it. I can't think of a single instance of why that would be a reasonable thing. I have seen implementations where somebody has built like a build farm and they're just really happy with like Docker being the solution for this. And so what they do is they basically just rotate those images like every day or every week, where like the underlying nodes associated with that Docker and Docker build farm are just wiped out daily or weekly. And I think if you were going to actually try and expose or build something like a D&D build farm on top of Kubernetes, where you could actually just use a particular cluster to handle image creation and image publishing, then I mean that's not the worst of the options, because at that point at least you can actually you just ensure that like those nodes are only ever used for building and pushing Docker images, and they are recycled on a regular basis. That would be a reasonable implementation of this, in my opinion. But generally speaking, I don't think that there's a good reason why you should ever do it. For example, people running Docker build. Yeah, I mean that's the reason people have to do it. But there are so many other solutions now out there. Things like image, by Just Fraz. There's stuff like Kaneko and Builda. So image is a project by Jess, still actively maintained. It gives you the ability to actually go ahead and build images without the requirement of that mounting. And then Kaneko is another one. There are a few other tools out there that you don't actually have to expose the underlying Docker socket to do those things. And I think these things are definitely improvements in the way that we actually manage those things. So there are other tools out there that'll let you accomplish that goal without giving up the underlying node. So I think, yeah, Builda is another one. I should actually show that one too. Somebody want to put those links in there for me in the chat? That would be really great. So Build It is another one that's pretty active. Build It's built again. It gives you the ability to build OCI container images. I think this is actually part of the open repository, crun, Scopio. Like there's a number of tools in here that are actually pretty interesting for things. And I've actually seen a couple of some podmeds in here. There's a couple of there's a number of tools inside of here that I think are actually pretty interesting. So might be worth checking out. All right. Oh, thank you, Roy. Okay. So, hold on. Got lost here. All right. So back to it here. So we've got our example. We were able to see. Excuse me. We were able to see the you know that this is actually working. And now let's have some fun and do some other stuff. Oh, that's another one. I think. Is that right? I'm curious. I think that yeah, Ingress is another one of those ones. It's a warn. It says extensions v1 beta 1 is deprecated. Now you should use networking v1 beta 1. So it's not removed, but it's another one of those ones that's been expired. So like gotta get your brain into like thinking about noticing when they're expired. So I saw extensions v1 beta 1 and was like, wait, that's another one of those expired ones. So that's pretty cool. So now let's play with some stuff, which I think will be fun. I'm gonna go back here and I'm gonna make a new directory. Move kind KRail. Make your manifests. So I'm going to move D&D and K its root into manifest. All right. Let's talk about D&D, and we'll also talk about this K its root thing, and we'll play with both of those things, and we'll make sure that they get shut down. So here's another example of a deployment spec that should not be allowed by this admission controller. Let's take a look at it. So this is a deployment using apps v1. It is going to run, and this is actually doing a lot of things good, right? So like in this particular manifest, I'm running as not root. I have an FS group. I have a run, all of these things set up. I'm pulling an image from my own registry, but I'm using a tag, so I'm expecting it to complain at me. And maybe we'll play with the idea of actually going and getting the right the SHA for that, so we can see what that looks like. But we can also see that I am mounting in the Docker socket, and that but I've got all of the other things set correctly. I have allow privilege escalation false, and I've got capabilities dropping everything. And the only thing that I'm really doing that's violating are two things so far as I can tell from this manifest. I'm violating the tag rule, and I'm violating the Docker socket rule. So let's try to deploy that thing. So if I do kubekettle apply -f deploy D&D, kubekettle get pods. Wow, that is surprising. Huh. So this was allowed through. Oh, I'm in the KRail namespace, but I don't think that there's an exception unless it's just a built-in exception. kubectl delete -f deploy d&d no proofs. KNS default. Let's try in the default namespace. Oh, there we go. Funky. Okay. So apparently, like it automatically invalidates the namespace that KRail is in. So if you have access to the KRail namespace, then you would actually have the ability to deploy and defeat this thing, which is an interesting hook. I didn't really think about that before. So, but now we actually see the thing that we were looking to see, right? So it's complaining about host bind mounts. It's complaining about Docker socket. It's complaining about an immutable image reference and the trusted image repository. And it's saying that the annotation, safe to evict annotation, which is not a policy that I saw in our output, is required for pods that use empty dir or host path mounts to enable cluster autoscaling, which is also valuable output. So let's do kubectl get deployment. And the deployment was totally shut down, so it didn't actually even land as a deployment, which is cool. Get pods, nothing. All right. Let's take a look at what's happening here. Kaneko is quite okay. Yeah, it's true. Build a +1. We are using Kaneko in our CI/CD cluster to let people build their images from within Jenkins. A+. Same namespace. Yeah, exactly. It was in the same namespace that KRail was in, and so I was able to deploy it. Validating webhook configuration ignores the KRail namespace. That's what I missed. Oh, that's what we're going to look at next, is the validating webhook configuration. As the webhook always ignores the same NS, which makes sense. It's configurable in validating webhook configuration. Is there a reason for that? That's true. Yeah, I mean, if you shut yourself down, how would that work out? How does KRail compare to OPA? And then that's typically to prevent completely working thing. Yeah, exactly. All right. Let's go ahead and take a look at the validating webhook. Let's see what that looks like, right? So we talked about the different policies. We played with them. We've looked at them. The next thing I'm going to do is actually create an exemption, and we're going to play with the exemption flow as well. But first, let's look at get. Let's do describe validating webhook. This gives us a pretty readable output. So here's the configuration for this config and the exemptions. So this is actually, it looks like that means, usually if you see like an exemptions thing like that, or a checksum for this, it means it's actually looking at the configuration of that config map, and if it gets updated, it'll take the update automatically. I haven't actually validated that that's the case. We're going to play with exemptions here in a second to see if that is the case, but that might be, but like if I see that in the annotations, that usually means that it's like a hook as part of the Helm piece, so that if I modify an exemption as part of that, then when Helm goes to deploy those manifests, it takes a checksum, and if it was a config only change, then we'll see that config change, and then it will automatically restart the deployment or redeploy the deployment, or mark it for a rolling deployment, because you will have changed the annotation of the deployment. And so that's like one way that we can actually manage that stuff. So let's look in here and see what else we see. So this is a validating webhook. Oh, hey, that's the thing I was going to talk to you about. I almost forgot. You see this kubectl Kubernetes last applied configuration? We're going to talk about that in a minute. I just wanted to point out that it's there. This is going to come in handy here in just a moment. So API version, it's an admission registration against v1 beta 1. It is a validating type, which is awesome. When you create a validating webhook, you need to actually provide a certificate that is able to validate the serving certificate of the webhook directly. Now, understand that this is code that I'm applying to the API server. I'm actually registering this webhook with the API server. This is not the code that's running. This is just me informing the API server, hey API server, there is going to be a pod running that will handle all of the work of this validation, and these are the coordinates that you, the API server, will use to interact with it. And so as part of that configuration to the API server, I specify a CA bundle, and that means this is the certificate authority that signed the serving certificate that the pod is using to protect its interface. And that way, the API server can validate that the pod is actually who it says it's supposed to be, especially if there are multiple of them, right? So it's actually able to validate that serving certificate is signed by a known authority, and that's actually where the known authority part comes in here. Now this is a self-signed CA. This was actually generated as part of the Helm template call. Moving down the list here, what else do we see? We say that it's going to be a service and that the name is KRail and it's in the KRail namespace. And then it's not at any fancy path. It's just serving at root there. It's serving as root there, and then the a port 443. Failure policy is interesting. Failure policy means you know what? I'm actually not going to try and define it for you here. I'm going to do this. Kubekettle explains my, every episode I give a shout out to Kubekettle Explain because it's incredible. Did I miss something? Validating. Failure policy. So this is me like looking into the API to see what that failure policy is going to do. What do you mean? What capitalization? Oh. And so this failure policy basically describes, a failure policy defines how unrecognized errors from the admission endpoint are handled. Allowed values are ignore or fail, and it defaults to ignore. So if we get back trash, we're going to ignore that trash. There's also an interesting one in side effects. Side effects states whether this webhook, maybe I'll put a fix for that, has side effects. Acceptable values are unknown, none, some, none, or dry run webhooks. With side effects, must implement a reconciliation system since a request may be rejected by a future step in the admission change, and the side effects therefore need to be undone. Requests with dry run attribute will be auto-rejected if they match a webhook with side effects unknown or some. There is another one. I guess it is actually just the failure policy. Like whether there's actually like whether to ignore it or not. The reason I call this out is because I believe that if the failure policy is ignore, that means that if the pod satisfying this validation control is not available, then we just allow the admission through. We don't deny that we don't deny those resources while the admission webhook are gone. Right, it fails open, exactly, right? And so in this case, it's actually going to say, like, if I were to go ahead and DDoS that validating webhook, or if I were to take it down or cause some problem with those pods, then that would mean that because the API server was not able to communicate with that validating webhook, it would allow anything through in that intervening time. And maybe we'll play with that here in a minute. But this is definitely the challenge of the webhook model versus having something that is an admission controller directly in front of the API server. This is one of the differences between leveraging pod security policies and leveraging something like a validating or webhook or OPA or that subtooling, right? In this model, if you're leveraging tooling like this, you are subject some of those race conditions that might leave you in an unprotected spot. But we did think about it, and that's why you see failure policy, right? If we set this to not ignore, then even if that validating, if that service that was actually doing the validation of this stuff was not working, then we would reject and say, the webhook is not available, so I can't leave that in place. Then what else down here? We have namespace selector, not in. We're going to ignore the KRail, which is why we were able to get the pod by earlier. That was a good point. Object selector, we're looking for all groups. We're looking for all versions. We're looking for create and update. So anything that's just a get or a set or a patch is not going to show up here. Well, I guess update would, right? But delete isn't going to show up here. We don't really care about the lifecycle pieces. And then those resources that we're watching out for are pods, deployments, replication controllers, replica sets, daemon sets, stateful sets, jobs, cron jobs, ingresses, which is interesting because, well, that's actually kind of interesting. So it means that what they're trying to do is basically highlight anything that could result in a pod that they want to match on, including pods themselves. So good catch putting pods in here. It's not just these things that create them. You can create them directly as well. So that's a good point. And then the scope is everything within that manifest. Side effects set to none and timeout set to 30 seconds. So if it takes longer than 30 seconds to validate it, because of that whole ignore errors thing, I believe it would be allowed in, again, fail open. So now we know all of that. Let's play with this a little bit more. So if I do kubectl apply -f, I get that. But what if I did kubectl delete all -n KRail? -n KRail. So it looks like we actually had the overlap there because there was still always a pod running. So this is actually a shout out to the fact that they're running more than one of these pods, right? So there was never an overlap in which we didn't have something running. It looks like in this case. But let's do this. Scale deployment -n KRail 0. We'll do kubectl get pods. We see them all terminating. So I'm actually kind of intentionally hindering this. So now I can see my pod, kubectl get pods. Here it is, container creating, and now it's running. So then I'm going to go ahead and do my scale again, but kick it back up to 3. And what that showed us is that same behavior, right? Because it's like fail open. That means that even though we cranked it down, we still allow that in, right? So now if I do kubectl get pods, that pod is still running because it happened in that race. It happened before. It happened in a time when there was no validating admission controller to block it. Now kubectl exec ti bash. So here I am running as Docker as not root. I think yeah. So this is interesting. Var run Docker socket. Haha. That's because there is no Docker socket. So whoop, that's not what I wanted to do. So what I'm going to do real quick is I'm going to do get what I'm doing here is I'm actually attaching my laptop directly to the cluster. I think I showed you this before in another session. What do we want to do this? So this is TGIK episodes 095. So there we're back in our stuff. I'm going to edit that D&D deployment. Actually, I'm going to move into D&D. And cat D&D no privs YAML. You can see I set a node name to links here. And so if I do kubectl get nodes, I can see I have a links node now running. And because I have populated node named links, I'm actually enabling that pod to be created on my node. Even though it's forward in version, things should work out okay. So if I do kubectl apply-f d&d no privs YAML, I should get denied, which is what we see, right? And if I do my scale down again, or if I put that into -n KRail, kubectl get pods -n KRail. So now I see that here, and it's running. And this is actually what I wanted to show you about with the Docker and Docker stuff. So let's jump into that D&D pod. So kubectl exec ti. This is why D&D is kind of like a kind of a sketchy idea. KRail D&D no privs bash. So here I am inside of my container on my link on my laptop here, connected to my host, right? And if I do docker ps, I can see all of the containers running on my host, right? So, for example, I'm going to pop open another window here just so we have enough context to really put together what's happening visually inside the screen, right? So over here, just so y'all are with me, I'm going to actually put this down here up below. So I am kubectl execing into a pod called D&D no privs, and I'm execing bash. Right? So now I'm running inside of that pod contextually, right? And if I do ls-l var run docker socket, I can see that the docker socket is mounted in, and it's mounted in as part of a read write against group 132. And if I do ID, I can see that when I started up this pod, I specified a GID of 132, which gives me, the user, 1000, even though I'm not running as root, the ability to interact with Docker. And this is what I mean by an unauthenticated API. So if I do docker ps, I can see all of those containers running on the underlying host. And if I do, and let's go ahead and start a new container from inside of the pod, because this is actually the thing that I really want you to understand about why Docker in Docker is maybe a terrible idea, right? So if within my pod, I do docker run -it bash, we'll do, -v etc host etc. So now I'm not running as root, so it's actually kind of interesting because of the way this is mounted in. I can't do anything to these files anyway, but I could cat etc or host I can cat stuff that is known about inside of this configuration, right? But because it's all owned as root, right? -al. Oh wait, oh, that's right. Contextually, I am root. Who am I? I'm root. So let's touch a file. Touch host etc flag cat capture Okay, so now I've actually got a flag file that I created inside of a container running inside of Docker and Docker. And if I exit back out of that Docker and Docker section, then I won't be able to have access to that file anymore. But if I go back to the node where my host is running, this is links over here, and I do cat etc flag, there it is, right? So I couldn't have done that as a user. And so that's actually why Docker and Docker is so powerful, is it gives us the ability to do all kinds of crazy things. Because inside of the Docker and Docker host, contextually what I'm exposing when I do this command, this is not the etc directory of the Docker and Docker pod. This is the etc directory of the underlying node. That's what I wanted to get across, right? The reason Docker and Docker is so interesting is because when we expose that Docker socket up, we're actually enabling the ability to make to contextually expose everything available wherever contextually that Docker socket is resident. And it's running on the underlying node, which means that when I provide that Docker socket to a container, I'm giving that container full control over the underlying node. It can do anything to the underlying node because Docker gives us an incredible amount of capability. And this is one of the things why Docker and Docker is like such a security nightmare. Just don't do it. It's really bad. And this is why I definitely shout out to Cruise Automation and those folks, and pretty much any tooling, including PSPs, to limit that capability because it's a big deal. Now, the other one I wanted to show you. Let's see, where else are we? So we've talked about some of those capabilities. Oh, that was the next thing we were going to do. We were going to look at grabbing the checksum for an image and using that to get past our problem of. So if I were to do in my cluster here, if I do kubectl run nginx image nginx replicas 3, then it will be denied because of the fact that it's using the, what else? It's complaining about there's no SHA-256 digest. So let's go back to our docs here, because I remember them talking about how you go about finding that image. So, boop. Boom, boom, boom. Immutable image reference, Docker inspect. So I'm going to pop open another terminal here. And let's take a look at nginx latest. So this grabs the repo digest, the digest for that image. And now if we kick back over to our terminal again, and we do kubectl run nginx image equals nginx replicas 2, then it accepts it, right? And so that was actually one of the tests that they are actually validating on. And so in this way, I can actually just go ahead and get through there, right? But let's look at a different way of doing this. So I'm going to go ahead and delete this deployment. I'll do kubectl get pods, kubectl delete deployment d&d. All right, so now what I want to look at is the exceptions policy, or the exemption. Maybe it's exemptions. Anyway, it's also here in the doc. Let's go ahead and look at that. So policy exemptions. So in my case, what I want to do is I want to enable the ability to exempt the image tag reference from my default namespace. I want to be able to use tags. No, the daemon is usually on the underlying host. Docker and Docker can actually mean two things, which is interesting. So Docker and Docker is actually, it can mean two things. It can, and I'm actually curious to see a poll. I did a poll on Twitter about this a while ago, but Docker and Docker can mean expressing the underlying node's Docker socket up into a container. And that is by far the most popular definition of Docker and Docker. The second version of Docker and Docker, which I think is more compelling, and I think is related to what you're talking about, Bogdan, is the ability to say, is the ability to grant enough privilege to a container such that within that container you can make use of those primitives that make up a container directly. And in that case, like, that is another interesting example of a thing where Docker and Docker can mean two different things, but if you give enough capability, you can do things like what we're doing with kind. And I can actually show you that real quick before we move on to the next part of this. If we do kubectl get nodes, and I do Docker PS, I can see all of the, I can do, actually, let me do this. Actually, I'll leave that alone. Okay, so I can see all of the the Docker containers that are running on my local machine here with the contextually within Docker on my host, right? And if I Docker exec in to the kind control plane, and I do KRail PS, I can see only those containers that are running inside of this particular node. And if I jump into a worker node, again, I can only see those containers that are running on this node. And on the underlying host, I cannot see any of those KRail containers, right? Docker PS grep KRail. Oh, I do, because one of the KRail images is on my laptop, but that's fine. But my point is that you're not seeing that there. Now, what's interesting also, if we look at this from the perspective of systemd CGLS, which stands for Control Group List, right? Then we can see inside of here, like, how that's actually broken up and like what's happening there. And so let's just jump in. So here is the Docker service. And we can see the Docker containers running, and these are all of the containers that are running inside of that C group. Now, this is the fun part. So this is a Docker container that's running, and inside of that, there's a container D service that's running. And that container D service then creates other containers. So this is another implementation of Docker and Docker, right? Wherein I've actually provided enough capability, enough privilege to the running container that it can then create new containers, which is kind of mind-boggling, right? You have the ability to provide enough privilege that a container inside the container itself has the ability to create new network namespaces and PID namespaces and all of those things directly. And in our case, we're leveraging containerd as a containerizer to do that with kind. But I don't want to get too far into it. Yeah. I mean, there's definitely a couple of clear definitions of how it works. I agree with. I like that definition better, Bogdan, because of the isolation that it represents. But fundamentally, that's not what people are doing with Docker and Docker. Kind of terrible. All right, let's play with these policy exemptions. I want to build an exemption that will allow me to remove the immutable image reference from my test. So let's go ahead and build that. So let's go ahead and let's look at it. So clear kubectl. I'm going to do this like in the config map itself. You probably would do that with a config map. You'd probably do that with a Helm chart, but I'm going to go ahead and roll the config map directly. Gen KRail. So this is the exception list that they have already. And let's look at the configuration one as well, just to see what else we got here. KRail config. Good. So we actually have the names of stuff, right? So here's our pod immutable reference. I'm going to yank that for later. And this is the full configuration, and you can do things like, and I like that that you can actually enable or disable or report only or true or false on each of these policies, right? So if I wanted to turn off that immutable reference for the entire cluster, I could just disable that here. And in fact, let's try that first. Get pods -n KRail. Still running. Okay, well it didn't rotate, so let's take a look at the logs. kubectl get pods -n KRail. Show labels. I always forget the labels. Name KRail, so kubectl logs -n KRail -l boop KRail. So I'm not seeing anything in here. I'm not seeing anything in here where it detected a change to the configuration. In fact, I still see that here, right? So let's go ahead and go back to our kubectl command, run nginx, replicas 3, and I'm still being enforced. So that means it's actually not doing a watch on the config. It's not doing a watch on the config map. So let's go ahead and delete pods -n KRail. Haha. Oh, I think we actually made, I think in our case we actually got away with it because, yeah, these are all still loading up. So we actually did win the race that time, right? Because it was actually fail open. So let me go ahead and delete this deployment. You could all delete deployment. And then I'm going to go ahead and deploy this again. And then we'll go back to our logs. And no error. And then if I do kubectl get events, that's another capability that we have here. We can see everything running. But let's cruise back in events, and we can actually also see that they've actually wired up events with the tooling itself, right? So if I were to try and deploy that tool again, so kubectl apply -f deploy dnd, kubectl get events. I don't see those things in the events anymore. I only see them in the output. I think it's probably because it's being shut down so quickly. I think that's relatively new capability, relatively new functionality, but yeah, they were using the Helm checksum. So if we were to use Helm to template again, it would work. But what's interesting about that is that it means that to add policy or to change policy, that you do have to reload those pods. And you can do that using the Helm template mechanism, wherein you just reapply the change. In fact, let's do that. So KRail, cd deploy, bim, So I'm going to go ahead and turn off the immutable reference again here. Actually, I'm going to go ahead and turn it back on. And then I'll do report only true. So then I'll do Helm template. So then we see what has changed, right? Our configure map, our config map was changed. Our exemptions are unchanged. Everything else is unchanged, including this. Oh, the secret was updated. Well, that is interesting. And so that means that the validating webhook and the secret were updated. I was rotating the certificate when I did this. The deployment itself was also configured, right? So in this change, because I modified the policy, what that triggered was a change to config map, which thereby triggered the deployment. Because the secret was also regenerated, that also changed the validating webhook configuration. So kubectl get pods, and if I go ahead and delete this guy again, delete deployment -n or nginx, kubectl get pods -n KRail. It's running, been up for 52 seconds, so I go ahead and do my deployment. And I still see that, that's good. So now if I do kubectl logs -n KRail name equals KRail. And what do we see here? Enabling pod immutable reference validator in report only mode. Kubectl get events. Okay, where do we see the report though? So it's using the events API, and it's also using the logs, but I don't see anything in the events API. And I don't see anything in the logs. Oh wait, there it is. Okay, good. All right, so enforced false, kind pod, level info, not enforced, namespace default, policy immutable reference, resource nginx. So there we're seeing the error. We're seeing, that's what I was looking for, was like, if we're reporting on it, I wanted to see what the report looks like. And so we're seeing that report actually refer to the deployment, to the replica set, to the pod. For some reason, that did not actually get expressed by the events API, but that is there. So that's cool. All right, the next thing I want to do, and this is going to be the end of it, I want to play with an exemptions API. So let's look at that real quick. So let's go into values. And let's cruise on down to our exemptions. So I'm going to go ahead and add an exemption. Resource name. Case root namespace default username presumably username is like who is actually doing the creation of the thing, and then the group, what group they're a part of. Exempt policies. So I am saying, I think what I'm saying here is for a resource name called KAceRoot, go ahead and let it be created in the default namespace, and let it get away with anything it wants to get away with. Don't question it for anything. So let's go do our redeploy here. And again, we can see what's changed, right? So we see the exemptions was configured. The config stayed the same. We see that the deployment was configured, and again, the secret and the validating webhook were also both configured. So we do kubectl get pods-n KRail, and that's all almost done. Rolling update style. And then I want to jump back into my examples here. I want to make sure I've given this thing the right name. KAceRoot. I need to grab the meta there. Well, actually, shouldn't have to. Okay. So, actually edit this one more time. So this pod is actually going to run as privileged, and it's going to run with host PID, and we're running as and that should be enough to get us there. So let's give that a try. So if I do kubectl apply -f root YAML. Oh, I think I knew that too. So let's go ahead and move back into. So what's happening here is I picked a bad name. That was my bad, because it's like DNS spec. So let's go into Helm, deploy Helm, Vim values. We're going to change this to that. And then we'll do our apply again. All right. So then back. So still complaining at me. Let's make sure our policy looks good. So kubectl get config map -n KRail exemptions. And we can see that we have two exempt policies, one for kube system, one for the default namespace with a resource name of KAceRoot. And if I again try to apply that, kubectl apply. That's not working. Now I did get this working before, I think, so it'll be interesting to see what's happening here. Pod KAceRoot head violation. I think maybe I know what's happening. And I think maybe it's a bug in the way that these are being evaluated. No, I'm wrong about that. All right. So I'm messing with the config map directly, and it's definitely not working for me. I thought maybe you would want it in a list form rather than two different exempt policies. That got us back up. If we do kubectl apply, one more thing I want to try, and then we're going to call it a day. What if I switch the order of these just for kicks? So D6. Okay, KRail's back online. Nope. Well, I'm not sure why that's not hitting, but naming does not match. Oh, is that my bad? Am I screwing that up? K8-root. And then cat. The name is K8-root. What did you mean? K8-root versus K8-root? K8 root? Oh, did I really do that? No, come on. Oh, that's embarrassing. Nah, it's still failing for me. Pod K8-root had violation. And if I look at my exemptions, kubectl. Yeah. Gotta set star for exempt policies. Let's try that. Hey, it worked. Just to make sure we didn't lose the race here. K8-root. Our pods are up and running. Haha, exemptions work. So it's typo on my part and a misunderstanding of what star means for external policy. So thank you, Dimitri, for bailing me out on that one. All right, I think we've been at this long enough. I'm going to go ahead and put my notes up in the repository. So if you want to play with this, you can actually follow along and do this entirely in your own session. And thank you, Cruise Automation folks, for letting me kind of dig into this. I think it was a really fun exercise into seeing what's available and like getting the opportunity to kind of talk about some of the things that are possible here. So I want to show you what K8's root is, and this is actually the last thing I'm going to show you. So if I look at K8's root, the pod itself, the manifest, like I said, we're actually using host PID, and we're actually using privileged. And then if I actually exec into this guy, kubectl exec ti K8's root bash. So what's interesting is if I do ps-ef, I see all the processes. Actually, I only see the processes running on the node that I'm in. But what if I wanted to take over that node? This is pretty interesting, right? So we can see that the first process is the PID1, and it's running the init system. So let's talk about NSEnter here. NSEnter is a tool that we talked about before that gives us the ability to enter into any namespaces or subset of namespaces for a particular user. With this one, I can actually do NSEnter -t for a target PID, we'll say 1, and -a for all namespaces. And then the command I want to run. And you can see that now I'm root on the kind worker. Right? So I have crketl ps, I have ps-ef. I could actually do the same thing. I could jump around to different namespaces as well. So NSEnter is very interesting. It's actually not my Vim config. I use a existing one from I got all this. Where did I get it from? Yeah, I'll have to share it. But yeah, it was like a part of a bundle that I found that actually had everything that I wanted. So I didn't play with it too much. It already has everything I needed. All right. Well, that is our session for the day. Thank you all for tuning in. Yeah, and the comparison to OPA, I think I'm going to do that next week or coming up here real soon when I do another OPA session. I think, but a lot of the things that OPA can do and this one can do are pretty interesting. One of the key differences here, I think, is that the Cruise Automation folks have actually developed a lot of the logic for determining resources that they're matching on with Go directly, right? And so, like, if we go back, get TGIK 095 episodes 095, and we jump into KRail here, and we look at the policies. So this is a policy that they defined, and this represents Go code that they've written and licensed under Apache 2. Awesome to see that stuff. And this is actually how they're going about validating or providing a resource, a response to this particular piece, like what the violation text is. So much of this could actually be, could use Rego. It could use the stuff. You could like greatly simplify the work that you're doing here by vendoring in things like OPA instead of doing that work yourself. You would still be able to define the response. You'd still be able to define the match, all of that stuff. Just changes the language that you're using, that sort of stuff. But at the same time, I think it checks the boxes for the Cruise Automation folks, right? And so there's probably, it's really kind of a decision on behalf of the project, like whether that really makes sense. But yeah, thanks again so much. It's been a great session, and I will see you all next time Again, a reminder, if you are going to KubeCon, make sure you go ahead and sign up for those sessions that you want to attend for KubeCon. So thanks again, and I'll see you all next time. Thanks a bunch.